the next chapter we're going to go into is chapter number 5, which is AAA, Authentication, Authorization, and Accounting. All right. Now, generically speaking, those functions all are distinctly different functions. One provides authentication of the person or individual trying to access the network resource or access to the device itself. Authorization is what that person can do once they've accessed the device, and accounting is us keeping track of what they're doing while they're doing it, right? With AAA, the goal is to either provide network access or administrative access. Network access AAA is us providing access to, the ability to gain access to the network itself, or what we call packet mode authorization. So it's somebody maybe coming in through dial-up or somebody coming in through a VPN connection, and they want to access the network, like send packets over the network. They're going to use AAA for that. That's packet mode authorization. Administrative access would be what? SSHing to a router for management purposes, telnetting to a router for management purposes, and so on. So two functions to AAA, either packet mode authorization, which allows you to gain access to network resources, and then character mode authorization, which allows you to get administrative access or command line functions, and so on. Authentication is something you are, something you have, something you know. We talked about that in a previous chapter. Authorization are the permissions that you're permitted once you connect to a device, or once you connect to the network. What are you allowed to actually do? And then accounting is the ability to monitor what it is that you're actually doing while you're connected, right? We want to account for the things that are being done while you're connected to the network. All right. Now, there are two ways to implement AAA in the network. We can do what we call local AAA, where everything is kind of self-contained in the platform itself. And typically local AAA is when you're trying to do character mode authorization. You guys actually configured that in the CCNA class to an extent. We didn't do the complete AAA configuration on the devices, but it's where we simply store all the credentials, all the authorization commands on the router or the switch itself, and we're not using an external server to provide those functions. All right, centralized AAA, you have an external server. That external server is there to act as a central repository for all of your authentication credentials, all your authorization policies, and so on. In Cisco, we use something called Cisco ACS, Access Control Server, to do this. All right? And Cisco ACS is now integrated into another platform called ICE, which is the Cisco Identity Services Engine. But ACS is still kind of a self-contained function within that platform. All right? With centralized AAA, it makes it a little bit easier to manage. We're not managing AAA functions on disparate systems across the enterprise. We're simply managing it on one server or one central location. So it makes it easier to manage it from that perspective. There are two primary protocols that are used in a AAA process. We have essentially three components to AAA. We've got the supplicant, which is the device that's requesting authentication and authorization. We've got the authentication, the authenticator, which is a router or switch that the device is connecting to. And then we have the authentication server, which is the back-end device that provides the actual authentication and authorization. As far as what we run on the authentication server, two separate protocols: Radius, remote access dial-up service, all right, or TACACS, terminal access control server. Radius uses UDP, specifically port 1645 and 1812 for authentication and authorization respectively. All right. And the 1812 and 1813 are what are used in modern networks today, but in the past it was 1645 and 1646. All right, but it is UDP based. The way that I remember that, TACACS being TCP based and Radius being UDP based, is TACACS has a T in it and Radius has a U in it, and that makes it easy to remember which one is which. Now TACACS is a proprietary protocol. Well, TACACS Plus is a proprietary protocol. TACACS didn't start as a proprietary protocol, but it became one when Cisco adopted it and kind of modified it to meet their requirements and their needs for AAA functions. When TACACS was originally developed, it was actually developed as an open standard protocol. And that was the original version of TACACS. All right. So in TACACS, TACACS functions provide essentially the same functions that Radius does, but it does it a different way. First of all, the data is transported differently. Within the transport layer, we use TCP instead of UDP. And then TACACS provides different ways of separating or combining the authentication, the authorization, and the accounting process. All right. There's some other things that TACACS allows us to do that Radius doesn't allow us to do. All right. So let's take a look at that comparison of the key differences between these two different protocols. Radius combines the authentication and authorization component in a single process. Now what that means is that if I've got my supplicant here and I'm connecting to a switch and I'm trying to gain access to the network, this is my supplicant, this is my authentication, my authenticator, and then I'm going to communicate to my backend authentication server. I send in my .1x request or my authentication request. That gets sent over to the authentication server. We then request the credentials from the client. We pass those credentials back to the server. And if the client is authenticated, we're passing back the authentication to the client saying you're authenticated. And by the way, you're also authorized to do these things. In other words, the authorization piece is sent immediately once authentication has been confirmed. We identify what the user is authorized to do from that point forward. Okay? TACACS does it differently. TACACS separates the functions into three distinct processes. Authentication, authorization, and accounting are all split. So I authenticate the supplicant, and then once I've authenticated the supplicant, each time that the client wants to do something on the network, we have to send messages back to the TACACS server to say, is the client authorized to perform this function? Then the TACACS server will respond with, yes, you can do that. The client does it. Another function, we go back to the server and say, can the client do this function? So the authorization essentially happens in real time, as opposed to sending the entire authorization profile once the client's been authenticated. All right. So this, when we use in Radius, it requires the client to accept all authorization specifications at one time, whereas in TACACS, it allows the client to make real-time authorization requests, and we tie in those authorization requests in real time to each transaction that takes place from the client to the server. The other thing that is different between Radius and TACACS is with the actual authentication credentials. Radius obfuscates the passwords that are transmitted between the client and the server. We use a shared secret key and hashing to hash the passwords, but the rest of the data, including the username, is sent in plain text. So the only thing in a Radius transaction that's not that is essentially encrypted is the password itself. Whereas in TACACS, we encrypt the entire data transfer. username, password, payload, everything gets encrypted in TACACS as we go back and forth from the TACACS server to the client. So TACACS is a little bit more secure in that regard. A AAA server allows us to centrally locate our authentication database, have a central repository for all of our authorization policies, and also have a single location to store all of our accounting records. Cisco offers 2 different AAA servers for your enterprise access control server and Cisco ICE, which is the Identity Services Engine. All right. And well, actually, not true. It is true from the ICE perspective, because ICE includes ACS. ACS was only a AAA server at the time. It only runs Radius and TACACS. All right. However, ICE, which includes ACS, does many other things, right? It does device posturing, device profiling, posture remediation if a device doesn't meet particular criteria, as well as including the ACS compatibility or the ACS functions with Radius and TACACS. Okay. The network attached devices, what we call NADs, believe it or not, are the ones that are actually configured within ICE and within ACS to act as the authenticators. Remember, the clients are not directly interacting with ACS, and the clients are not directly interacting with ICE. They are communicating to ACS and ICE through these NADs, these network attached devices that are acting as authenticators. So you can kind of think of those guys as little proxies to proxy all these authorization and authentication requests. AAA can also integrate, or AAA servers and services can also integrate to third-party solutions like Active Directory, LDAP, and so on, so that we can have a single repository for usernames and authentication credentials and so on. We don't necessarily have to store all those credentials and all that information directly inside of the ACS server. So the network devices, which act as the authenticators, relay the TACACS or Radius messages back to the AAA servers. There are some devices that can actually directly interact with Active Directory LDAP, essentially taking their local AAA configuration and extending it to an LDAP or Active Directory domain, and that would be like a Cisco ASA. Some other devices as well do the same thing. All right. So what does ACS provide that ICE doesn't, or vice versa? What does ICE provide that ACS doesn't? Both of them support interactive communication with Active Directory sources, LDAP, Radius, etc. Both of them provide the ability to use as an identity store and store data to determine what your authorization policies are going to be. In other words, what is the user authorized to do in the network? All right. ACS provides the ability to do TACACS and Radius on the same platform. ICE didn't up until the latest version. Well, not the latest version. We're well past 1.4 at this point. So ICE actually kind of this restriction doesn't really apply anymore. It has a Radius and TACACS built into it. Okay. But the benefit that ICE provides that TACACS and Radius didn't is this ability to do device profiling, posture assessments against devices. We can do centralized web authentication for guest services like wireless guest services and so on. The Radius and TACACS within Cisco ACS don't provide those functions. Only Cisco ICE does. Has anybody here worked with ICE before? Anybody heard of it? No, you have? Okay. It's essentially a network appliance, and it provides all of these functions.
How expensive is it?
It depends on which features you license and what you do, but it's less than $1 million. No. It depends. It runs, it's a few $1,000s, In a big enterprise, it can get up to that price, but not really in a small enterprise. Maybe $5,000, maybe $6,000, $7,000. Huh? Take 70% off of that. That's right. And you're getting it for a real deal. Okay. So we're going to progress through some of the different AAA functions that we can configure in our network. We're going to start by looking at local authentication and authorization. All right. Local authentication and authorization. This is different than saying I'm going to put into my device password Cisco login, or I'm going to put into my device enable secret, right? With local AAA, we're actually configuring AAA parameters in the device. All right. In order to enable any kind of AAA, whether it's localized or centralized, the first thing you have to do is enable the AAA features on the platform. And we do this by executing the AAA new model command in global configuration mode. Be very careful with this command though, because when you implement this command, all of the legacy authentication methods go away. Like a password applied to a VTY line is no longer available. Okay. And login local is no longer available. So it's very important that once you start to go down this path, that you configure everything with AAA, not just turning the feature on. All right. The AAA authentication command, AAA authorization command, and AAA accounting commands allow us to actually define our policies. So we've got kind of a complete configuration listed on this slide. So let's break down each one of the configuration pieces. AAA new model turns on the feature. And then we have these things called method lists. A method list can be used to identify an authentication method or a list of authentication methods, authorization methods, and accounting methods. In this case, we're specifying AAA, authentication, login default, local. What that says is that our login authentication, which would apply to things like enable secret, logging into the device using SSH or Telnet, we are going to change the default method list. This default references the name of the method list. In this case, it's default. And we're going to use the local AAA configuration for all authentication on this device. Does that make sense? We're using the local database, the local username database, which is the usernames that we specify in the platform as our authentication method.
Then the previous period that you start entering.
Sorry?
You said, so then I start adding entries to.
Correct.
None
Correct.
Of the previous ones were carried or grandfathered in.
Right. Now there are some restrictions on how we add these different methods. You can add a method for TACACS, you can add a method for radius, you can add a method for case sensitive local, you can add a method of none. So there are many different methods you can add. So let me actually pull up the router here and show you AAA new model. So that enables AAA. By the way, if I do no AAA new model, all right, and I type AAA question mark, all of my AAA configuration options go away. because I haven't actually enabled the AAA feature. So by doing AAA new model, now you can see when I type AAA, all of the AAA configuration options are available to me now. Does that make sense? All right. As soon as I type AAA new model.
Oh, I can't, but I don't have anything to do.
Well, let me show you. So if I go into line VTY, well, let me turn off AAA new model. No AAA new dash model. Line VTY 015. Log in. Password. Sorry?
There's here, and there's a question there saying that going back is not supported.
Oh, I'll show you. Yeah. Changing the configuration back to no AAA new model is not supported. In other words, when I switch to AAA new model, when I go back to no AAA new model, it doesn't restore my configurations that I lost when I went to AAA new model.
Oh, okay. But
all right.
So what, I'm now wide open?
Yes.
Oh, okay, that's what it's doing. It's not restoring, it's turning it off.
You're still turning off the feature. You're not restoring the original configuration you had prior to enabling the feature. So now if I do a show run section line, I can see my traditional authentication methods on my line, password and login. If I type AAA new model, do show run section line, all of a sudden, login is gone. The password's still there, but it's not really used. Password's there, but it's not used. But login is gone. So if I try to connect to these VTY lines now, it will fail. All right. So now I can start to set up my AAA authentication method lists by typing AAA authentication. And you'll notice that I have lots of options here as well. All right. I can set the banner that's going to be used when I'm starting my authentication process. I can specify what method I'm going to use for .1x authentication, what method I'm going to use for my enable password authentication, what message I'm going to use for my basic logins like SSH and Telnet logins. What is my password prompt going to be when I try to authenticate? PPP authentication, and so on. What is the username prompt that I'm going to require when somebody goes into the system? Right? So lots of configurable values here. But if I go ahead and say AAA authentication login, I have two choices here. I can modify the default list, or I can create my own list. So let's say I say AAA authentication login no auth. So I'm creating a method list called no auth. And then I can specify the method I want to use to authenticate. Am I going to authenticate using the enable password? Am I going to authenticate using group radius or group TACACS? Am I going to authenticate using Kerberos? Am I going to authenticate by using the password that's set on the line? Am I going to authenticate by using a local database? Am I going to authenticate by using a local case-sensitive database? In this case, I'm going to choose none as my method. And then I could say AAA authentication, login, VTY, local case. All right. Go into line con 0, AAA authentication, AAA log, AAA, why am I not coming up with it in my head here? Authentication, Ugh. If I can spell authentic, why is it not letting me do it? Let's try line VTY 04. Authentication, login. Why is it not letting me do it? That's right. Thank you. I'm tired. It's been a long week. Login authentication, and then I specify the method that I created, right? So login authentication VTY means that now when somebody connects to the VTY line, we're going to use the local case, the username database, but the usernames are case sensitive. That's what the case means. Go to line con 0 and say login authentication no auth. So now I've applied that method list to that port. Does that make sense? So exactly, the console port doesn't require you to authenticate. The VTY lines require you to authenticate using the local case sensitive database. All right.
While you're doing all this configuration, it seems like the safety net situation.
Yes.
You might turn that off at the very end when you know everything else is working well.
Right. Now, the reason it's called a method list, because if I go to AAA authentication login, I'm going to change VTY now, and I'm going to say group TACACS local. Now that is actually now technically a method list. I'm going to try to authenticate against the TACACS server. If the TACACS server is not available, then I will log in against the local username database. Does that make sense? If the TACACS server is not available, I'm going to authenticate against the local database.
I don't have to know anything about the TACACS server. It's just out there in the network.
Well, there are some TACACS configurations you have to apply in the router to point to the TACACS server. This device needs to also be added to the TACACS server so that it will know to accept transactions from the device. All right. So there are things that you actually do have to do for this to work. Now, what will not happen is if the TACACS server is available, if the TACACS server is available and authentication fails, it does not fail over to the local database. The only reason the second method would be used is if the first method is unavailable. Does that make sense? All right.
You said it's like basically the data device which you authenticate to, or do you have to
Nope.
try a bunch of times to say, oh, well, I guess TACACS is better?
Well, no, the router does that automatically, right?
So
The router knows if the TACACS server is available or not.
yeah, but you don't.
But if the TACACS server is not available, the router doesn't deny your authentication. It tries to use the same credentials against the local database in real time. It's not requiring you to go ahead, and you would hope that either the account you're using is in both, or if the login fails, then you try to use an account that might give you local access.
That means you have to worry about authentication being synchronized.
Right.
You have a local account with certain passwords.
Well, typically what will happen in that case is that the local account is an emergency account.
Yeah. Okay.
That gives you access to the device in the event that TACACS is not available.
It should be a personal account. It should still be monitored, but it's
Right.
You never have to worry about changing it. You never really use it.
Right. So these are called method lists, and it allows us to specify different methods for authenticating, right? Here they just simply change the default method list to say I'm going to go ahead and use the local username database for authentication and authorization, or authentication, excuse me. And then on this one, the no-auth is the name of this method list, and we're saying that the authentication method in this case is none. All right. Here, we're specifying the authorization levels, right? AAA authorization method list. Exec stands for execute, like user exec mode, privilege exec mode. And in this case, we're going to go to the local router to identify what commands are authorized by the user or for the user once they've authenticated. All right. And we apply the authentication to the console port, or we apply the authentication to the V2Y lines. If we are integrating into the back-end system, in other words, we're not using local authentication, we've got a back-end server, the client communicates with the router, which is now the authenticator. The router then passes that information over to the TACACS server or Radius server, and then that authorization occurs that way. So this guy is kind of like a proxy to all of these different requests that are going back and forth. So how do I configure my device to communicate with a TACACS server? I create a TACACS server group. In this case, the TACACS server group is called TACACS-SVR1. I specify the IP address of the TACACS server, and the string that's being used is how the TACACS server identifies the router. So there's some authorization and authentication between the authenticator and the server in this case. And on the TACACS server, I would set the same secret string, which then would allow us to authenticate. 1, 2, 3 different commands here. AAA authentication login default group TACACS local. We just talked about that, right? I'm changing the default authentication group. The first method for authentication is group TACACS. The second method for authentication is local. It will allow you to switch them around, but you would never get to the second method, because when would the local method ever be unavailable? It wouldn't, right? Again, we're not checking against both methods to see if the username might be in one versus the other. If the first method is usable and authentication fails, we simply stop the authentication process at that point. AAA authorization, another method list. And then we're saying in this line right here, AAA authorization commands, for all my level 15 commands, I'm going to authorize those against TACACS or the local database. Obviously, there's a lot more to this than what we're seeing in these slides, though. There's a lot more to the configuration of these functions than what we're simply seeing in the slides here.
Can TACACS and ICE be, would you have 3? Would you have
Well, ICE is TACACS.
Okay, well, that's what I was trying to, okay.
Yeah. TACACS
So,
runs
when I
inside of
configure-
ICE.
right. Well, I'm sorry, an ACS.
ACS is also TACACS.
Okay, so
ACS is just the name of the product.
and that's where I have what I'm saying is there an ACS device and an ICE device?
Not typically.
Okay, that was.
You're going to run one or the other, right? If you're going to have ICE, you're going to have the Radius and TACACS function automatically built in.
Right.
So there would be no reason to run a separate ACS
But you
server.
started with ACS server, and then you wanted to introduce new features.
Right.
You might bring in an ICE server.
ICE appliance, yeah.
Right, ICE appliance.
You bring in an ICE appliance, but then you're going to migrate all your TACACS stuff over to the ICE appliance anyway. You're not going to have 2 separate devices.
Okay, so you wouldn't.
Yeah. All right. By the way, ICE is virtual. Okay, it runs in VMware. I can give you guys a copy of it that you can run on your workstation. Okay, and actually it comes fully featured for 90 days when you install it. So if you take a snapshot of your VM, yeah, then you can use it in your lab environment indefinitely. All right, but ICE is not a. It is a virtual machine, right? Yeah, you run it on a UCS server. I have ICE running on my laptop in VMware Workstation. Yeah.
Anything that supports loading up an ICE.
A VM, yeah. Anything that supports loading up a VM will support the deployment of ICE.
Any unified communication server can do that.
Yep.
I mean, is it runs Windows or runs like Linux in the background? Like, what is it?
It's an appliance, so it basically runs a proprietary version of Linux that Cisco, it's kind of like Call Manager and Unity and everything else that Cisco has. It runs on a VM, right? You can integrate it with GNS3 if you're running it in a VirtualBox or VMware. So yeah, ICE is readily available. You can probably find it on Google, but obviously because this video is going on YouTube, I have to say that that would only be for learning purposes. Obviously, you don't want to install it in a production environment. But, okay. All right. The accounting piece, several different ways of implementing accounting. Typically accounting, well, not typically, it's basically what it is. Accounting is the process of identifying when things occur, right? And I'll start the accounting once you execute commands, and I'll stop the accounting once you've done accessing the device and so on. In this particular example, we're specifying the TACACS authorization is run for level 15 commands. That's this line right here. Right here. Is that the right one? No, that's not the right one. This line right here. Here, let me highlight it. So this line right here is what we're referencing there in that first bullet point. Specifies that TACACS authorization is run for level 15 commands, and that AAA authorization is of configuration commands is enabled. All right, and that would be the second line here. The accounting commands are used to set up the different accounting functions. Accounting, of course, is used to log whenever a user logs in and logs out. Well, not when they log in and log out, but what they do while they're logged in. And accounting is enabled when a user gets an exec shell and for level 15 commands. So we're seeing that here and here. All right. It's a little bit redundant because if you're going to get an exec shell, that's automatically going to also account for all the level 15 commands that you execute. All right. All right. By the way, accounting is the only function that's not allowed to be done locally. You can do authentication and authorization locally, but you can't do accounting locally. That has to be done on a TACACS server. SSH. We went through the whole process of configuring SSH. SSH provides a much more secure method of accessing our iOS devices, much better than Telnet because everything is encrypted, typically with AES encryption. Now to configure SSH on a platform, the first thing that has to happen is you have to change the host name of your device from a default host name. So you can't simply leave your device called switch or called router. You have to change the name of the device. Okay? The next thing is you have to set the domain name of the device. We talked about this in the CCNA class, right? Why do we have to do this? because we're going to generate RSA key pairs. Tomorrow we're going to talk about cryptography. I don't want to take a whole lot of time in this lesson talking about how key pairs work in public key infrastructure and so on, because we're going to have that same discussion in another lesson. All right. However, RSA, Rivas, Shamir, and Edelman, the three dudes that came up with this concept of asymmetric cryptography, said, okay, we're going to generate a private and public key pair. Now, when it comes to SSH, what is the purpose of generating this private and public key pair? Is it used for authentication? Nope. It's not used for authentication because it's self-signed. So the certificates themselves really can't be verified. Is it used for encryption? Kind of. It's used to establish the encryption parameters. It's used to establish the shared secret key. It's not used for encryption directly, but the certificates are used to derive and share that bulk encryption key that we're going to use during the session. Okay? So we need to generate that RSA key pair. We set up our username and password on our device, and we set up our VTY lines to authenticate using that local username and password. Or we can use local AAA like we just talked about in the previous couple of slides. So let's take a look at the whole configuration. The host name of the device is router. We cannot generate RSA certificate pairs with a default host name. So the first step would be to change the name of the router to some other name besides the default. The next would be to set the domain name. In this case, we set the domain name to thinktank.local. The domain name does not have to be resolvable. It doesn't have to be a registered domain. You can make it whatever you want. But the domain name in combination with the name of the device is used to generate the key pair. So you can see that right here, core-rtr.thinktank.local. The next step is to generate our crypto keys. And we use the crypto key generate RSA command to do that. In this case, we're generating a set of keys with a modulus of 2048 bits. The minimum recommended key space for asymmetric cryptography. I mean, certainly you can use something smaller like 1024, but if you're following standard security guidelines, you need to have at least a key space of 2048-bit keys. And these are the keys that are actually literally used for the cryptographic process. All right, how many bits in the keys? 2048. At that point, once these keys have been generated, and when I say keys, I mean what? I'm talking about the certificates, right? The X.509 certificates that get generated, the private and public key pairs, that's 2048 bits. All right? Username admin, secret admin password. This is not AAA, by the way. Right? Well, we know it's not AAA because we're using the login local command. I could use local AAA in conjunction with this configuration. It would still have a username and a password. But in this case, I'm just using pre-standard or pre-AAA configurations. And then I'm also disabling telnet on the VTY lines by putting in transport input SSH. Transport input SSH says you're only going to be allowed to run SSH on this interface. On these VTY lines, telnet is no longer supported. So somebody explained to me the general process. When a client connects to a router that has SSH configured, how does that session get established in a secure manner. I'm the client, I SSH to a router. What's the first thing that happens? The router responds to the client with what? The public certificate. It sends its public certificate to the client. The client then yells and screams and says, I don't trust this certificate. Are you sure you want to accept this certificate? You guys have seen those messages before, right? Why does the client scream about the certificate? Because it's not signed by a third party. I can't verify the true identity of the device I'm connecting to because the identity hasn't been verified by a third party, a certificate authority. But I'm going to go ahead and accept that certificate, that public certificate. And then what is the client going to do with that information? It's going to generate an encryption key. The client is going to generate an encryption key, but now that encryption key needs to be sent back to the router. We don't want to send that encryption key over public domain. So we take the certificate that we got from the router, we encrypt the key with that certificate, and the only way to decrypt the key is how? With the corresponding private certificate that's never shared, that only the router knows. Once I have this bulk encryption key, I can then start to do the encryption, the AES encryption for the channel itself. All right. So I know that was a lot of information. Let me see if I can pull up a pretty diagram that describes that same process that we just talked about. SSH process. All right. Establish a connection. SSH protocol version, software version, SSH protocol software version, algorithm negotiation. All of this is related. That's not a very good diagram. It's an okay diagram, but it's not really telling us about the certificate exchange. Yeah. And maybe it's not so easy to find one that's pretty. But you get the idea, I believe, right? See, I'm not going to give up just yet. Let me see if I can take a look at a few more here. There we go. Client initiates the connection to the server. The server sends its public key and negotiates the parameters of the session over the secure session. The user logs into the server host operating system. Okay, this one's not even that great either because it didn't show any of the key exchange processes. Maybe one of these days I'll create my own little diagram. All right, but you get the idea. Asymmetric cryptography, and we're going to talk about this tomorrow when we get into the cryptographic chapter, but asymmetric cryptography doesn't really provide a method for doing bulk encryption. First of all, asymmetric algorithms are very slow, they're very process intensive, they're very complex algorithms. Whereas bulk encryption algorithms are very, well, they're relatively benign, they don't require nearly as much computing power, and they're very quick. So we tend to use those bulk encryption algorithms to encrypt and decrypt the data that's going back and forth. All right. Again, we'll see that in the cryptography section a little bit later on. Another aspect to managing this communication process, or at least the authentication process to a device, is to manage the privilege levels. Now, Cisco devices have 16 different privilege levels, 0 through 15. The three predefined levels are 0, 1, and 15. 0 privilege level doesn't give you access to anything. You can do the enable command, you can do the disable command, you can do the help command, you can do the exit command, and you can do the logout command. So being in level 0 doesn't give you access to anything. You can't even do show commands in level 0. So nobody ever really goes to level 0 in a Cisco device. When you connect to the console port of a device, or at least by default, you go into something called user exec mode, which is privilege level 1. And this particular level provides you access to some basic show commands. You can do some pings, you can do some trace routes, some basic troubleshooting, but you can't manage the platform completely. You're not going to be able to reload the device. You're not going to be able to manage the file system, etc. Privilege level 15 gives you the keys to the kingdom. When you're at level 15, you get access to every command. You get access to every command. All show commands, all configuration commands, all file management commands, every single command in that device. So there are a bunch of, those are the 3 canned levels that exist, but then there are a bunch of configurable levels that exist between the base level and the privilege level. In fact, it's levels 2 through 14. By default, there are no commands applied to levels 2 through 14. We have the ability to reallocate or reassign commands to different levels. We'll take a look at some configuration examples here in the next couple of chapters. Well, not the next couple of chapters, the next couple of slides, I should say. In fact, here's an example. Privilege exec level 7 clock set. Now, clock set is normally a level 1 command. But what I've done in this case is I've moved the clock set command to a level 7 command. Why would I want to do that? Well, probably not that particular command, but there might be multiple commands that I want to move to different levels so that I can provide this basic multi-level admin scenario. Of course, in order for us to be able to use level 7 access, I have to provide a way to authenticate to level 7. Yes, sir.
For giving people permissions, does it do all the subsets? So like if I say privilege exec level 7 show, would it do all the show commands like show ID brief, show, all that?
You mean if you're authenticated at level 7 and you type show question mark?
No, if you're in a 15, you're setting it up for everybody, and you want somebody to have all the show commands, whether it be show IP brief, show interface, or show router. Can you just say exec level 7 show?
Yes.
And it will come on?
In fact, it's actually, that's the way it has to be. That's one of the limitations to this method, is that it doesn't allow you to control subcommands. So unfortunately, you can't do, you can limit specific types of show commands up to a certain point. For example, show IP or show IPv6. But you couldn't say, for example, do show IPv6, show IP route EIGRP. Right? So there is some granularity, but not all the granularity you would expect. We use another thing called parser views to do that kind of granularity. All right? The other thing to keep in mind is that if you authenticate at one level, it automatically includes all of the privileges at the levels below. So if I authenticate at level 7, I'm getting all the commands at level 7 all the way down to level 0.
So when I plan these special levels, I have to think of that hierarchy.
Yes. And quite frankly, this is not something we typically use in an environment. Because if your goal is to do command level authorization, you're going to use TACACS. Honestly, because the other methods, this localized method isn't very scalable. And there's some limitations too. All right. So if I go type enable 7 and authenticate, now I get the clock set command. If I go to level 1, I won't have the clock set command anymore. All right. So let me show you an example of what the limitation is of these different show commands. So I'm going to go into my router here, AAA. So I'm going to actually not AAA, privilege. All right, level 8. All right, privilege exec level 8. Sorry. And I can specify the commands. Notice it doesn't really list the commands. It just gives me this word line. Line meaning tell me what level 7 commands or level 8 commands should be. So I'm going to do a show IP route. Okay. Now if I do a show run section privilege, let's see if it actually keeps the show IP route. Notice what it did. It actually did 3 different commands. It allowed show, it allowed show IP, and it allowed show IP route. So let's see if it restricts show IP interface brief. Show IP interface brief is supposed to be a level 15 command. If I type end and I type disable, show IP interface brief is not available at level 1. All right, so config T. Let's do enable secret level 8 Cisco. And now I'm going to type enable 8. Oops, do enable 8. Oh, come on. Enable 8. Show privilege. Now my current level is 8. Show IP. And I get all the show IP commands. So even though I did show IP route in my privilege command, it automatically gave me access to all the show commands, which is unfortunate, right? Show IP interface brief, I can do that command now. So that is a big limitation to this approach. It doesn't provide that granular command level authorization that you might want if you're running something like this. If you want that level of granularity, what you want to end up running is something called role-based CLI. Role-based CLI enables the authorization for administrative access based on an administrator's role. We create these things called parser views, which allow us then to assign commands to specific functions. All right? But the nice thing about this particular approach is that it does let us get very granular as to which commands are allowed to be run and which ones are not allowed to be run. All right? In order to configure these parser views, the first thing that we have to do is enable the root view, which is basically like enabling the features. Enabling the features. All right? So the root view must be enabled to configure individual parser views, and authentication to the root view is based on the enable secret password. So the first thing I have to do when I'm configuring this process is I have to set my enable secret password. Let me type enable, config T, enable secret, Cisco. All right. Then I would type enable view, or sorry, excuse me, enable view. All right. That takes me into the root view. Notice it said AAA user blocked. Enable view requires to be authenticated by non methods. Please use the appropriate method. Enable view root. Sorry, that should work. Oh gosh, I got to turn off my AAA.
In your example, it has it.
Oh yeah, it has to be on, actually. To do parse reviews, you have to have new model enabled, right? And I don't have it enabled. So what I meant to say is I need to do AAA new model. Now I can enable my root view. So I type, I already did the enable secret. So now enable view root. And that should enable my, why is it not letting me go in? Oh, config T, do show run. I was messing with the AAA authentication commands earlier, and I've haven't given myself a way to authenticate. So line AAA. Sorry. Include AAA. Yeah, I don't have a default authentication method list. So AAA authentication, login default local, and that should do it. All right. So enable view root. What the heck's going on? Enable view requires to be authenticated by none methods. I wonder if it's because I'm connected to the console using the no-auth method. Let me try that. Login authentication. Let's do PTY. I just locked myself out because I didn't put in a username. There's an easy way to fix that though. I'll turn off the router and turn it back on again. And while that's starting up, let me go ahead and go through the configurations here, and then I'll go back into the command line and show you some of the configurations. All right. So they're enabling AAA new model because the only way that you can configure these parser views is if you have AAA enabled. And then they're enabling the root view, and what I should see is successfully switched to view root. The prompt doesn't change. I've essentially just started this parser configuration process. All right, so let me go back into the device. It didn't start. Why didn't it start? All right, let's delete that guy. Now I'm getting all kinds of errors in GNS3. Of course. All right, try this again. I don't believe I was in level 8. I do believe I had switched to level 15 because I did type enable. When you type enable without a level specified, it automatically assumes that you're trying to authenticate to level 15. All right. So, for example, if I type disable here and I type enable, show privilege shows me at level 15. So I'm going to go ahead and type enable secret Cisco or Cisco and AAA new model and enable view root. There we go. Now it's authenticating me. So it authenticated me to enable to allow the root view to be enabled. And I didn't get the syslog message to indicate that the root view was enabled. But now at this point, I can start to configure these parser views, these different parser views. And the way it works is you establish the views that you want to create. So I'm going to create a view called VPN admin. All right. So I say config t parser view VPN admin. All right. And I need to assign a password to this view. So if somebody wants to authenticate and get these privileges, they have a way of authenticating to that view. So I'm going to call, I'll put the password as secret1. So that is the password that I use to authenticate to that view. And then I can specify which commands are allowed in this particular view. So commands exec, all right. And then I can specify all show commands, configure terminal if I want, all crypto commands, and so on. I'm going to be even more specific. I'm going to say, okay, the only commands you have available to you are show crypto IPsec SA and show crypto ISAKMP SA, which are two specific commands for verifying the operation of VPN tunnels. So enable view VPN underscore admin, put in the password, show privilege, doesn't show up anymore. Show view doesn't show up anymore. In fact, the only commands I have available are do exec, enable, exit, and show. Show question mark. There's the crypto I added. These other ones are there by default. Show crypto. Now there are many, many different crypto commands I could use, but the only ones that are tied to my view are IPsec and ISAKMP. IPsec, SA. All right, ISAKMP, SA. So you can be very, very specific as to which commands are actually executable by the client that's authenticated to that view.
You have to, is the part that's going up that they're going to allow commands that have to be short lived. It's not actually word sensitive, word matching. If you had said,
okay.
out the W,
Yeah, let's test that. Let's test that theory, right? Enable. Cisco. So now I'm back at level 15. Show privilege is now available command because I enabled to level 15. All right. So config T, parser view, VPN admin, command exec, include. Now let's do another command. Show Let's do IPRO. And yeah, let's do that one too. Show IP int BR. All right. Enable view VPN underscore admin. Authenticate. Show question mark. There's my show IP. IP question mark. Interface. Okay. Now, this is where we lost some of that control, right? Show IP interface is not a command that we can restrict beyond interface, right? But show IP route, we can, right? Once you get access to show IP route, you get access to all the types of routes that are available. We didn't actually say that you're allowed to run show IP route EIGRP, but it was automatically assumed. So not every subcommand has to be entered, but you get the idea. Now, what's the plus side to this versus privilege levels? A lot more granularity, right? You have a lot more control, and you can limit commands specifically. With privilege levels, if you give somebody a certain privilege level access, they're going to get access to that privilege level and everything below it. 7 to 0 or 10 to 0 or whatever. With the parser views, you're literally only getting access to the commands that are in your view. And by the way, you can lock down configuration commands. You can lock down all kinds of different commands. All right? All right. I know we're getting up on our time limit here. Let's go ahead and at least finish this chapter. Obviously, we're not going to do the next 2 chapters like we had originally hoped, but that's okay. We'll get through the rest of this chapter, and then we'll just push forward tomorrow because I know you guys have to go study for your test, okay? To access the different parser views, enable view, authenticate to the view, and then you get access to those particular commands. You can even assign views to users, to a username. So when somebody authenticates, the view is automatically applied to that username authentication. Does that make sense? All right. So that is the end of that chapter. We will